question, how would you build your own encryption system? Let's just look at a word. So I want to use the word bail. And let's say this is P for plain text. How might you encrypt this? You might just start sending letters randomly. So you might send B to C, A to Z, I to K, and then L to D. And you might be a little smart, right? You might say, okay, if I have another B, I'm not gonna just randomly send it to some letter like E. I'm gonna keep it, obviously, with what was already mapped, so I'm gonna keep it with C, right? So we might just kind of think, okay, like we can just map it in a pretty straightforward way. And this seems like a fine idea, so why don't we just continue with this? And we can formalize this kind of method of mappings with something called a Caesar shift. This is like the most elementary like encryption system that we have. I think this is like, I think this is when it was like 60 BC, super old. But anyways, the idea with this system is that we have our plain text. So instead of just going from like, right, instead of just saying we just have like, kind of doing it randomly like this, like P, whatever. Instead of doing it randomly, we formalize all these mappings. So, okay, I have my plain text, and I'm just gonna write out the alphabet. And then underneath it, I'm gonna shift all my letters by a certain amount. So here, let's say I shift every letter to the left, right? So we're gonna have A becomes Z, B becomes A, C becomes B, D becomes C, X becomes W, right? We're just gonna shift everything to the left. So that's why it's E1. We're shifting 1 to the left. Right, so for example, if I wanted to do like, now if I have bad, this is gonna map to that. Okay, so that's one shift. 2 shifts is gonna look something like, we're just gonna shift 2 letters to the left. So here, look like this, V, yeah, okay. We're gonna shift like that. So we've shifted everything 2 letters to the left. So X, right? So if we have like V, W, X, Y, Z, right? So Y is E1, and then just like example. Right, so here we're just looking at Y. E1 is gonna map it to X, E2 is mapped to W, and so on and so forth. So if we just take a word, we use our same word, bad. This is gonna be Z, Y, B. Okay, this is pretty simple. But the problem with this is, if we know that our plain text has been encrypted with a Caesar shift, we only need to check a finite number of different possible encryptions in order to break it. Because if we think about this, right, we shift 1, we shift 2, and eventually we're gonna loop all the way back to where we're gonna shift, and we're gonna get back to what we started with, since it's only 26 letters. So we're only gonna have 26 possible different ways to encrypt, and this 26th one is gonna map, this is the identity. So it's gonna map All right, if we shift A 26 times left, it's gonna go back to A. B is 26 times back to B, so on and so forth. So it's cyclic. So we only have a finite number of encryption methods to work with the Caesar shift. So how can we do better than this? And we can kind of build this. We can kind of build on this idea. With something called, I should know how to spell this. Something called the Vigenère cipher. I looked this up a little bit. Well, obviously a little more than a little bit, but to figure it out. But this isn't the person that actually is. It's misattributed to this person. It was actually first developed then in 1553, around this time. But anyways, how this works is we're gonna make a giant table of the alphabet. So okay. Okay, and now across this, right, so it's gonna be 26 by 26, so it's huge tables. Obviously I'm not gonna fill it all in, but I'll fill the first 2 rows. So here we're gonna start writing out, we're gonna write the alphabet starting from A. So we're gonna have A, B, C, X, Y, Z. Here we're gonna have B, C, D. And now if we look, right, A goes to B, B goes to C, C goes to D. This is E1. Now instead of shifting to the left, we're shifting to the right because we're reading from the top. But it's a square, so it's not going to matter which way you think about it. But so we're shifting everything to the right by 1. X is going to map to Y, Y maps to Z, Z maps to A. Okay, so then this is going to be E2. So we shift all of these, we shift everything here to the right by 2. So this is going to be A maps to C, D, E. Or you can think of this as just writing out the alphabet starting from this letter and then all the way until you get to the end. But I think it's, either way you think about it, but I think it makes more sense for me to think about it as a mapping, as just like a Caesar shift. But here, right, we're gonna have X mapped to, X is mapped to Z, Y maps to A, Z maps to B. Okay, and we do this the whole way down. So we do it for all this. So we're gonna have whatever 26 times 26 is, a ton of different entries here. And now how do we use this to encrypt something? So again, we have some plain text. So let's say our word here is gonna be dogs. Okay. Now we're gonna introduce a keyword, and this can be anything. And it doesn't even need to match the length of this, but it can. And so for explanatory purposes, I'll have it match. So keyword is gonna be fire. So now what we're gonna do is how we're gonna decide how this encrypts, like what this value is here. We're gonna find all the places where these letters match. So I wanna find the intersection of D and F, the intersection of O and I, G and R, and S and E. Okay. So now let's say that D and F, right? Obviously I did ellipses, so I'm just gonna like roughly say where this is. With with the actual table for this, you're gonna have all the letters, but obviously I didn't write it all out. So D and F, let's say it's here. Okay. O and I might be somewhere like here. Okay. G and R might be somewhere in between, so might be somewhere like here. And then S and E might be somewhere like here. Okay. And I've looked all these up ahead of time. And this should give us these letters. Okay. So this is gonna be where they all cross, and so now our encryption is gonna be IWXW. Okay. So this is what we're gonna map to. Okay. And we can already kind of see why this is immediately stronger from just a normal Caesar shift, is because now, because this table, this cipher method is made up of different Caesar shifts, we can have situations like this where multiple letters, where if we think about it like we have if we just think about it like this, we have dogs. And, right, in this system, O maps to W, but so does S. So this is already a lot harder to break. And yeah, this is how the Vigenère cipher works. Hopefully this was interesting. Okay, bye.